Hey guys, welcome to week 5 of the discussion. Today we're going to be going over functions asymptotes. I am struggling really bad to say that, but this week has been a little tough. Just a newsflash, I am moving into a new apartment I'm currently in, and so the lighting, the sound, everything is totally different. But we're gonna get started. First of all, I do a job. I work at Chick-fil-A. Been working there for 6 years. I'm currently a shift lead, and I'm looking to step into a role of director of operations. And I've worked there since I was 17, so I've learned a lot, grew a lot, and it's been an amazing journey. But to start us off, I have a lot of notes and graphs on my laptop here, and then I have all of basically everything I'm going to be sharing written down here. So to begin, I'm going to read out the question. We'll go from there. It says, so given Rx equals x over x to the third minus 6x to the second plus 11x minus 6x divided / over x over 3 plus 8. Our first question is, what is a domain? So in order to find out the domain, I always start with graphing. As soon as I can graph that, I can see how our domain is. So I kind of wrote it here a little bit, but I wrote it down a kind of similar one to what my graph is on the computer, and I'll put those in the note tabs too as well. But as we can see here, this is similar to what the graph is going to look like. Our line is ongoing, so it's neither negative nor positive. It's negative and positive, so it's a graph that keeps going. Therefore, our domain is going to be parentheses minus infinity, negative infinity / infinity, because there was no ending point, and because x squared equals negative 8, then it has no real solution, so therefore the line is just continuous. So our second question is going to be, are there any removable discontinuities, holes in the graph? If so, what are the coordinates of it? So a hole occurs if a factor cancels between the numerator and the denominator. So x minus 1, x minus 2, and x minus 3. I can show you right here. X minus 1, x minus 2, x minus 3. Since they all go and there's no skipping, there is no removable discontinuities, and that's just because there's no like actual canceling. There's not like an actual real number that's cancels between both the numerator and denominator. C says, what is / are the vertical asymptotes? So the denominator does not equal 0, therefore there is no vertical asymptote. So if we want to go from the denominator just right here, this x plus 8 right here is going to equal to 0. It doesn't actually equal to anything. That is just, if it needed a real number, it would equal 0. But since it does not equal, there is no vertical asymptotes. Question D says, what is a horizontal asymptote? Horizontal asymptote, the highest degree term dominates. So if we put Rx equals x to the third, x to the second, is going to equal to x. So 3 is greater than 2, therefore there is none. However, if it was 2 to 3, then we would have a denominator, but then we would have a horizontal asymptote, but because there's none, as you can see here, because this equals to x and 3 is greater, therefore we don't have to worry about any type of horizontal asymptotes. So E, the obligate slant asymptote. So every time we're doing slant, it's going to require the polynomial division. This is the longest part of this. So we're going to start off with our actual problem, which is, again, I have a whole lot written here. So I'm going to kind of just hold it down and go down the line. So our actual problem, x to the third minus 6x squared plus 11x minus 6 divided x to the second parentheses plus 8. So when we get there, we're going to start with doing like terms. So x to the third divided by x to the second is equal to x. When we get that, we are going to plug it into the parentheses on this side. So x x multiplied x squared plus 8. And if we do that, we're going to x squared plus 3 plus 8x, because x kind of just goes under right here. It goes next here. So after that, we are going to subtract. We're going to subtract our actual function here, our equation. We're going to subtract that from the x to the third plus 8x. And when you're subtracting, use like terms such as 11x minus 8x. So we'll do 11x minus 8x. That's going to give us 3x. The two x's over here, x to the third, is going to be x negative 6x to the second, because the x's cancel out. And then the 6, because it has nothing to plug in, it'll just be minus 6 right here. So I know there's a lot of explaining, but that's pretty much it. Okay, after that one, we are going to reassemble, and now we are going to get negative 6x squared minus x squared. So the x's are going to cancel since they're like terms. It's going to give us negative 6, and the x cancels. Then we'll have negative 6x. We're going to plug that into our little equation we got here. Multiplied x to the square plus 8x. So then we're just going to be using we're going to be multiplying with the parentheses. So 6x squared, and then we'll do 6 times 8, which is going to be 48. So that's going to equal 6x squared minus 48. After that, we're going to get 6x squared plus 3x minus 6, and then, because that is exactly what we got for our first equation right here. Then we're going to subtract that, minus 6x squared minus 48, and that's going to equal 3x plus 42. Again, look at our like terms on our little parentheses. So minus 6x squared minus 6x, the x squareds are going to cancel. It's going to give us 3x, and then plus the 42. So our slant is going to equal y equals x plus 6. Therefore, and that is 2 because our x is infinite. So to kind of set it up, we're going to have our x is equal to x minus 6 plus 3x plus 42 equals 0 over x squared plus 8. And again, if we combine those like terms, we'll come up with the x minus 6. So asymptotes, a line that curves, approaches, but never touches. And then after that, we are going to determine if the x-intercepts, again, I can look at my graph that I have on my laptop here already, and those can give me some y-intercepts. So because it equals to 0, we're automatically going to have parentheses 1. Our first x-intercepts are going to be 1, 2, and 3, and the y is to be determined, so they're going to be 0. So it's going to be x equals 1, x minus 1, x minus 2, x minus 3. They're going to be our first x-intercepts. Our y-intercepts, so basically we're going to get our two numbers from the very beginning right here, negative 6 and 8, and then we're going to plug those in. We're going to put those on each other, so 6 over 8 is going to be equal to 3 over 4, which if we turn that into a decimal point, it should equal to 0.75, so that's going to be our y-intercept, and we'll start off with 0. So 0 to negative 0.75, again, because we converted this fraction to a decimal. And then it says to plug in. Our last question is going to be show how to find a few points on the graph. So just to be certain, it says plug in any values. If you ever want to like graph anything or try to graph something, plug in any values for x. In this case, you can use 4, you can use 0.25 to the function to find more points. You'll just plug those into the actual equation and then come up with like x equals this, x equals 1, x equals 2. But yeah, if there is nothing else, I'm going to go ahead and show my graph. So again, as soon as I can get my graph going, it pretty much helps me. So you can have our x-intercepts, 1, 2, 3, our slant, a couple other of points right there. But I hope you guys got a little bit out of this. If not, it is totally cool. Have a phenomenal weekend. And if there's any questions, please comment down below and love to chat. Thank you.